So let's say you're seated peacefully in the exam, minding your own business, and they decide to ask you a situation like this. It says ball A is thrown vertically downwards from the top of a building 80 meters high at a velocity of 12 meters per second. At the same instant, a second identical ball B is thrown upwards at a velocity of 30 meters per second. Ball A and ball B pass each other after 2.135 seconds. Ignore all effects of air friction. So it's a nice diagram, we can see that. The first question says, give the direction of the acceleration of ball B while moving upwards. So one thing we know is that ball B is a projectile, and we know that it is in free fall because gravity is the only force acting on it. So the direction of the acceleration will be downwards because gravity pulls it down. So even though it's moving upwards, but it's always accelerating downwards. Very important. Now, what about the next question? It says, calculate the velocity of ball B the moment it passes ball A. Very important. So if you revisit your statement, they told you that ball A and ball B pass each other after 2.135 seconds. In other words, they are asking you to calculate the velocity of ball B after 2.135 seconds. So we need to look at ball B and analyze what is it we are given about ball B so that we can choose the correct equation of motion. So here we understand we are given the initial velocity, which is 30 meters per second. We are also given the time. We also have the acceleration. It's 9.8 meters per second squared. So with this information, we can easily use the first equation of motion. But before we can do so, we need to decide on direction. So let's say upwards is chosen as positive. Now we can safely go to the whiteboard. So we say, according to the first equation of motion, well, it's not really the first equation, but let's call it the first equation so that you are familiar, or rather you get a general idea of what I'm talking about when I say the first equation. So it says VF equals VI plus A change in T. So we are looking for the final velocity, but the initial velocity is 30 meters per second. And it's positive because we said up is positive. The acceleration due to gravity is a constant, but it's negative because it's going downwards. And the time we are given, it's 2.135 seconds. Then if we go to our calculator and type this value in, everything here, we find that the velocity after 2.135 seconds will simply be 9.08 meters. Sorry, meters per second. And then your happiness is complete for this one. So what about the next question? What does it say? Let's see. It says, calculate the distance between ball A and ball B 2.5 seconds after it was projected. So the it there, it causes a little bit of confusion because then to which ball are they referring if they say it. Do you see that? Well, you should know that it's referring to both balls because they were dropped, or rather thrown, sorry. They were thrown at the same time. Are we fine? So what is the procedure in finding the distance in this case? The first thing we need to do is to determine how far has ball A traveled from the top of this building after 2.5 seconds. We also need to know how far has ball B traveled from the ground after 2.5 seconds. Then next, we have to determine the height of ball A and the height of ball B above the ground. Then we can find the distance between the two balls. So let's go to the whiteboard and kill it once again. We are here to destroy these things. So in order for us to find how far has each ball traveled, we need to analyze and see what is it we are given regarding both balls so that we can choose the correct equation. So if we look at ball A, we know the initial velocity, we know the acceleration, we know the time. The same applies for ball B. So we can easily use the third equation of motion. Yeah, the third one. Yeah, this is the third one. Yeah, it is. Yes. But now we need to be specific. So we tell them that let's look at ball A. If we consider ball A and we want to know how far has it traveled after 2.5 seconds, then this is the relevant equation to use in this case. So we say the ball A is moving downwards with a velocity of 12 meters per second. So it becomes negative. But we want to know how far it has traveled in 2.5 seconds. The acceleration is negative as well because it's going downwards. And then we say the time is 2.5 seconds. So if we go to our calculator and substitute everything, so we find that it's negative 12 into 2.5 plus half into 9.8, which is negative, and then we get that. So we find that the displacement will be negative 60.625, which is just 63 meters. So the negative here tells you it's going downwards. Fine. Now let's consider ball B. We still want to know how far has ball B traveled after 2.5 seconds. So the initial velocity of ball B is 30 meters per second. It's positive because we said up is positive. And then we have our nice 2.5, our nice negative 9.8, and then this is what we have. So if we go to our calculator and type in everything, we find that the displacement for ball B will be 44.38 meters. So this is what we know, right? Now, before we can do anything, I want us to draw the sketch once again so that we can make sense out of these values. Remember, we said the first thing we do is to calculate how far has each ball traveled after 2.5 seconds. And we have succeeded. We did the first step. So this is how the situation looks like. The total height of this building is 80 meters. And let's use blue for ball A. So we say ball A has traveled up until this point, downwards. Do you see that? So we say it's 60.63 meters. But this is from the starting point, very important. Next, we have to find the height of ball A above the ground. So think of it. If the distance from the starting point to a certain point there is 60.63 meters, then what is the distance from the ground to the very same point? Do you see? So you say 80 minus 60.63. So we know that ball A is at a height of 19.37 meters above the ground. Very important. Then we go to ball B. So ball B, this 44.38 we see is actually the height above the ground because it started moving from the ground and then it goes up. So it's the height above the ground. So what is the question asking from us? Well, we know that ball B is here. We also know that ball A is here. So if this is the case, then what is the distance between these two balls? This is what we are looking for. Do you see that? The pink portion there. So in order for us to get the pink portion, we say this distance will be 44.38 minus 19.37 meters. And if you plug this into your calculator, you find that the distance between these two balls will simply be 25.01 meters. Over and out. So let's look at the last one. Well, the last question says, sketch a position time graph for the motion of ball A till it reaches the ground, as well as for the motion of ball B until it passes ball A. Use the ground as the zero position. Clearly indicate the time at which the balls pass each other. That's what we say. So remember what we said in the beginning. We said upwards is chosen as positive. Do you remember that? So let's draw our axis. So we say this is how it will look like. And this is also how it will look like. The ground is the reference point. Now, if we look at ball A, we know that it was dropped from a height of, in fact, it was thrown, sorry. It was thrown vertically downwards from a height of 80 meters. So this is how your position time graph will look like for that ball. But if we look at ball B, this one was thrown from the ground. So you'll say it starts at a height of 0 up until it passes the ball A. Do you see that? So we only draw this up until this point. And they asked us to show them the time at which these two balls will pass one another. So in the statement, they said they pass each other after 2.135 seconds. So that is what you say. Of course, you need to label it as ball B. And the black one as ball A. So these are the only things you needed to show in your diagram. Of course, you need to label this as your position time graph. So you'll say position is on the y-axis, measured in meters, and then your time is on the x-axis, measured in seconds. And then you are done. So thank you so much for watching this video. I really hope it helps a lot.